Hello, business research students. In this video, we're starting to talk about experimental design. Experiments are the only way that you can establish cause and effect relationships. There are many scenarios where experiments can be used in business. As a first example, imagine you've got this manufacturer of luxury cars and they want to launch a global brand campaign to reinforce the image that people have of their cars. The campaign is scheduled to last 18 months and will be rolled out worldwide, where they'll have advertising on TV, print, and in electronic media. They're going to use the title Bravura, and a renowned advertising agency developed 3 different campaign concepts to determine which is the most effective. The car manufacturer is going to test their effects on the brand's image. How can a car manufacturer test the effectiveness of these concepts? They can use an experiment where they try the 3 different potential marketing campaigns on different groups of people to see which one seems to be the most effective. Another example is you could do a study on absenteeism and the steps you could take to try to curb it, and incentives that you could possibly give, like maybe you could give bonus days off or offer cash or prizes. Then you could test those different incentives on different companies. So which of the different offers actually help people to not be absent from work more? That's another example of an experiment. Finally, a third one. One problem with layoffs is that there's always a sharp drop in the commitment of workers who do stay with the company. You could do an experiment to see if layoff really does cause employee commitment to drop off or if there's something else affecting the situation. In this case, you want to establish cause and effect between layoffs and commitment, so this would be an experiment. In order to conduct any of these experiments, you have to be able to identify independent versus dependent variables. What is an independent and dependent variable? Well, to distinguish between them, you always ask yourself, what variable causes a change in the other? The independent variable is the one that affects the other variable, and the dependent variable is the one that gets changed. So, as an example, imagine filling in the blanks all of the time. It should be that the independent variable causes a change in the dependent variable. So, let's say you're trying to determine if there's a relationship between temperature outside and the cost to heat your home. You should first identify your independent and dependent variables. Ask yourself which one causes a change in the other. Does it make sense to say the temperature outside causes a change in the cost to heat your home? Or the cost to heat your home causes a change in the temperature? Obviously, we cannot cause changes in the temperature, so it is the first situation that makes sense. Temperature causes a change in the cost to heat your home. The variable that comes first, the one that causes the change, is the independent variable. The one that comes second is the dependent variable. So that is step 1. You need to be able to identify independent versus dependent variables. Make sure you try the learning check on your lesson page for more practice telling these 2 variables apart. Remember, independent comes first. It causes the change in the other one. We're also going to talk about some conditions for cause and effect relationships related to the independent and dependent variable. First, the independent and dependent variable should always covary. That means that a change in the dependent variable should be associated with a change in the independent variable. Let's go back to our temperature and cost to heat a home example. These covary because in general, we can say that as temperature decreases in the winter in Canada, let's say, it's going to cost more to heat your home. That's what covarying means. There's this change in one that causes a change in the other. Number 2, a change in the independent variable should come before a change in the dependent variable. So there is a time sequence. Think about again the example of temperature and the cost to heat your home. A change in the temperature outside, which is your independent variable, will come before you see a change in your heating bill for the cost to heat your home. As the temperature drops, your bill will go up. And number 3, in order to establish the cause and effect relationship, you should always control for the effects of extraneous variables. This makes sure that the change that you see is actually due to the relationship between the independent and dependent variable and not other things. So, for example, do you know any other factors besides temperature that can change the cost to heat your home? Of course, there are other factors like the size of the house. So the bigger your house is, the more it will cost. The amount of insulation you have, the age of your furnace, all of these things can impact the cost to heat your home. So if you were going to do an experiment on how temperature impacts the cost to heat your home, you'd have to try to control for these other factors. What that means is use similar size houses or use houses that are similarly insulated or of the same age of furnace so that you know the impact on the cost to heat your home is from the temperature and not from these other things like the age of your furnace, your insulation, or the size of the house. So these are all critical in being able to use an experiment for cause and effect relationships. You need to be able to identify which variable is independent, which is dependent, and these conditions must be met for your independent and dependent variables.